Storage matters for successful AI projects. This is the third in our series around AI and cognitive solutions. So I'd like to welcome you. My name is Neil Hart. I work in the plan function at CSI, and I'll be running through a couple of introductory slides this morning before I hand over to our guest speaker, who's Matthew Fordham from IBM. Some of you may know CSI, some of you may not. CSI is an enterprise performance partner where we are obviously a very focused technology company, but it's an outcomes biased approach that we follow. We realize that people aren't buying technology for technology's sake. They're buying technology to solve a problem. We concentrate on helping our clients with business objectives and creating a perpetual edge over the challenges that they face. And we realize that the speed not necessarily one tomorrow, where competition can come out of any different direction. We see three major digital forces at work that affect the competitive landscape in any market: digital acceleration, digital disruption, and digital threat. And they're all linked to each other. Digital acceleration really goes to the speed of business in the digital world. People don't want to wait 2 or 3 seconds for a website to change its screen. They don't want to wait for delivery. They don't want to wait in a queue. They want immediate feedback. And we can see this in the preference for chatbots or conversational assistants on websites where perhaps the interaction is not as rich as you'd have with a human, but at least it's immediate, and that's what people are preferring. Digital disruption refers to the competition coming from non-traditional competitors. A very old example would be Nikon and Canon finding out that more cameras are sold by Nokia and Apple than by them, because every mobile phone has one camera in it, or these days 3 or 4 or 5 cameras advertised. Brick and mortar retailers obviously getting competition from online only startups whose cost of startup is far less than opening up stores and high streets. So between the speed of acceleration and non-traditional competitors, we have a scenario where companies have to innovate really fast, and that brings with it the increased digital threat. The number of new viruses, malware, and so on is increasing every day. Traditional approaches to antivirus don't keep up fast enough, and certainly manual processes can't address these things. So we're seeing more and more automation and indeed machine learning and artificial intelligence approaches to solving these problems. CSI addresses these digital threats with 5 major technology capabilities: architecture around platforms, data protection, data management, disaster recovery, and of course cyber protection, where we address all the way from strategy and advisory all the way through to SIEM and SOC as a service. And we also have an applications focus, as you do have to these days, as it's the cloud migration. You're migrating the application from one platform to another. You're not obviously migrating the infrastructure. And what we're talking about today is enterprise AI, or grown-up artificial intelligence, and the optimized platforms that you need to do advanced business analytics in real time. But as I mentioned earlier on, the technology is just the means, and the outcomes are the end. So when you go and buy an electric drill from B&Q, it's not driven by the desire to own a power tool, it's because you want to drill a hole in something. And that's the same with technology, and especially cloud and AI infrastructure. We're trying to solve a business problem. And I think we see, every organization has 4 fundamental outcomes: growing the business, increasing revenue, increasing markets, expanding geographically, saving money, innovating, so going after the competitive edge. It's often said if you're not the disruptor, you will be disrupted. So how does technology help organizations to innovate and produce new offerings to their clients? And obviously protection. You don't want to do any of these things if you're putting your reputation at risk, your data at risk, or your client's data at risk. In order to do that, we follow something we call a 6I process, which follows a life cycle from identifying the business challenge, or what is the outcome we're trying to achieve, imagining the possible solutions, choosing one, and then creating it, integrating it with existing processes, and obviously having a continual improvement for that solution, and the whole thing wrapped up and immunized against threat and risk. And I mention that because part of our cognitive solutions approach is to have identify and imagine workshops around cognitive solutions. And we'd like to invite anybody on the call, contact CSI, and we'd be happy to run one of these introductory workshops with you. Really looking at the first 2 steps of the 6I process, identifying the business outcome, a fundamental error in approaching AI is to say we've got a lot of data, what can we do with it? The approach really should be, I've got a problem, let's see how to solve it. Once we've identified the challenge, we can start then exploring some of the possible solutions in the imagine phase. So very much like to invite you to contact CSI. We run a complimentary workshop, sort of a half-day, one-day workshop to begin the process of identifying and imagining cognitive solutions. So by way of introduction to what Matt's going to talk about, why are we looking at cognitive solutions today? What's the imperative right now? And we see a bit of a perfect storm going on around data and performance. And these are the 2 fundamental inputs to a successful machine learning project. The more data you have, the better the model will be. If you train an AI model on a small sample of data, it's not going to be representative of the problem you're trying to address. So we need lots and lots of data. The other thing we need is immense compute power, because there's no point in having a 3-month, 6-month project just to analyze the data. As we saw earlier on, one of the digital forces is a digital acceleration. So we need immense compute power, and until recently, that's out of reach for most businesses. So the big supercomputers live in government, in the military, in the academic world, but not really in business. What's changing though, right now, is we do have masses of data. Digital business transactions, online shopping, social media, Internet of Things, so cars, fridges, Fitbits, or other fitness monitors are available. All of these devices are producing data, and that data can be gathered and processed and analyzed. And the other thing that's happening is that there is now affordable GPU-based high-performance compute based on a pay-as-you-go model. So you don't have to pay hundreds of thousands of pounds for a high-performance machine. You can rent the amount of time you need and then stop paying for it when you're finished. And typically, the creation of the machine learning model is where you need that high performance. Once you've created the model, running it can be done on a different platform. So the hybrid cloud or the multi-cloud approach is very much in vogue, looking at machine learning solutions. And the other part of the age of implementation is getting AI out of the lab and putting it to work. There are 2 different creative processes that we're looking at here. One is invention and the other one is innovation. And an easy definition is that invention is about creating something for the very first time. So you could imagine the Wright brothers might be saying they invented the airplane, but there's been a huge amount of innovation that followed that initial invention. So the first plane didn't have wing flaps, obviously didn't have all the avionics that exist in today's aircraft. So taking that first invention and creating value and changing and adapting and enhancing is really what innovation is about. And I think that is the point where we are now with AI. Artificial intelligence as a topic, as a discipline, was invented in the 1940s. Alan Turing and some of the very early work that was done by IBM. AI has been invented. Now is the time to get it into the real world and start solving problems and innovating. The potential to create value in the business, in the business world, is immense. Trillions of dollars of value can be generated through AI. That's not R&D. That's putting AI to work properly. So that really was by way of an introduction. This particular webinar is looking at the impact of storage for AI. As I mentioned, data is the fuel for a cognitive solution, and lots of it. And that's really what Matt Fordham's going to talk about, and I'm going to hand over to him now. Matt.
Thank you, Neil. That's great. Thanks very much for your invite to this webinar today. It's really good to be here, and thanks for all of you for attending live or listening to the recording. As Neil said, my focus here is around storage for AI. I'm a technical manager over at IBM as part of the storage team, and I work with a team of technical specialists to help customers really think about storage, a storage strategy, and a strategy that can really help them look ahead to how to get started with AI, how to think about AI in the future. And I think Neil was absolutely spot on in terms of the timing for AI right now is very much mostly exploratory for many businesses. We are obviously working with those that are ahead, if you like, early adopters, and we've really helped from an IBM point of view with our approach and strategy when it comes to not just storage, but also the platforms for AI. But we've also obviously learned a lot around the challenges. So really what I wanted to focus on was not so much the importance of AI. I think you can look back over the previous webinars with my colleagues to understand a bit more about the reasons for AI and the benefits. I like to look at this as AI is proving itself useful for those early adopters. It's increasing the margin potential, typically around 15% improvements in bottom line numbers. So it's starting to prove itself where AI is implemented. What I want to focus on is, as Neil said, the data is absolutely key to a successful AI project, and then it's also the export of an AI project is again data. So actually thinking about storage and how to manage and work with that data is a real critical part to the whole journey. So I'll position some of the challenges around data and storage, how we solve them, how we address them, just some ideas around what we have in terms of our offerings. So let's get started with some of the challenges at a high level. And really the key first challenge to highlight is that the overall data volume and quality is one of the major inhibitors really in terms of getting going in the first place. So I've got data all over the place. I have data in different storage systems or on servers or in cloud solutions. And how do I actually make sense of all that data? How do I pull it together in the first place? And then how do I take out the items that we really need and effectively sort out the quality? And quite often, that's the job of data scientists that have been employed to make sense of data, whereas actually they spend 80% of their time sorting out the quality in the first place. The data management is absolutely a critical challenge as well. Goes hand in hand with the volume and the quality. It's what tools do you use? How do you actually move data around? How do you manage it? And really compounding that is the skills gap of those sort of tools and offerings and and really just in terms of people really managing data in this way of being able to put it to some other use. So challenges that you may well relate to, and when you really are looking at AI projects, it can seem incredibly complex, and I think knowing where to start is absolutely half the battle, or in many cases it's most of the battle. Quite often we'll see customers deploy an AI proof of concept or proof of technology, and quite often that can be done in cloud resources because that seems a very simple and easy way to get it going. But actually the reality of that solution then is it's not really built from the data, as we've mentioned, as Neil mentioned. The actual data, your data, is your gold. It's what really will make a difference. And putting AI projects and proof of concepts into either a small pocket of the overall business or in a cloud resource somewhere else where it's difficult to actually transfer data to is not always helpful. So knowing where to start with a relative AI project that is going to be valuable to the business is really a major challenge. And this is certainly something that I'll talk about how we address really with blueprints and sort of an approach to building solutions and thinking about data pipelines. And as I mentioned, quite often we'll see these projects built on a business or a project by project basis, and that will often lead to then silos. So even if the project becomes useful for a particular use case, you can end up with a very disparate own data sets and own set of data and generating its own results. So effectively you end up with a disparate environment where AI is effective in small pockets and there's no real single source of the truth. So we certainly see that we can lay out a journey to AI, or this is often referred to as a ladder, an AI ladder within IBM. And there are just 4 key steps on this ladder, but like all ladders, if you're any way with the same mindset as myself, if I climb a ladder, I start confidently, get about halfway up, and that confidence soon starts to erode the higher you go. But if your ladder is footed, or if you've got any kind of guardrails around the ladder, then it becomes a much more simple thing to climb. So we're using the term of AI ladder just to try and resonate with the fact that there are steps to go through, and we can really help from our perspective throughout that journey. So initially there's the collect phase, making data accessible in the first place. As I say, it's often half the battle is really knowing where to start, but certainly actually making sense of the data you've got, how to bring it all together and make it simply accessible to the AI solution. There's the organize phase, which is really sorting out what you truly need and what you don't need. And there are lots of the sort of early adopters. There are some of the advanced users of high-end analytics that will all testify to the fact that the organization of that data is critical rather than wasting resources, mining through useless data. Of course, you want to try and do what you can to clean up the data in the first place. So we've got a lot of focus and development that's gone into tools specifically designed to help with that organized phase, which I'll touch on later. The analyze phase is really the part where you have the actual, let's call it a drag race. This is the part where you fire up the engine, you run the AI system and the platform, and that needs to be running at full speed and getting the most most bang for the investment. This is where a lot of companies and vendors, certainly storage vendors, focus on the analyze phase because that's where they feel that it's the most needed piece of storage design, making a very fast rocket ship storage platform that can support the GPUs and the processors that have been put into the AI solution. So fast storage becomes quite a flagship piece for some, whereas actually those first 2 phases are almost just as important, if not more so, before you get to that sort of analyze and training and machine learning phase. And then after you've successfully deployed AI projects and you've therefore then created more gold in terms of the data that's coming out of it, it's about how do you infuse that whole process through the organization, not just have another project that sits there, which is successful in its own right, but in a small environment and not really contributing to the overall business. Or how do you apply what you've learned throughout the rest of the business? And that's where you need a huge amount of focus on the data and how it's handled and how you re-ingest that data, put it back to a better use and more results. So 4 simple steps really, where we bring in significant technology to help from the storage and data point of view. If you had to put this onto a slightly more complex picture around how this starts to look in an environment, again, we've effectively got the same pillars across the top: the ingest or collect phase, the organization phase, the actual analysis, and then training of models, so machine learning, deep learning, and then sort of bottom right, the inference is the part where you re-ingest and you go around the cycle again. So this is a typical schematic of an AI solution, and you really do need to think about a data pipeline that runs throughout this. And you'll hear us talk about the AI ladder and how we can help think about an overall AI solution. And when that solution is built, and the way we help there is to bring blueprints and reference architectures so that you can stand up environments based on a tried and tested platform. That includes the compute, the GPU, networking, and the storage. But when you're then looking at your AI architecture, the data pipeline is hugely important. The ability to move between these phases, to get going in the first place and to move through the phases, is extremely important. And many vendors don't think about these steps. So I'll come back to this picture and I'll talk about some of the ways that we help. But really, if you think about what could be the challenges here, it's moving from a point where you can ingest data in the first place. So that could be edge use cases, it could be mobile apps, it can be web pages, it could be sensors. If in machines, it could be flow sensors, temperature sensors, all of that kind of thing. So you can think about the millions of different scenarios where you've got a data ingest point, and capturing that data might be simple if you've got the system set up in one way for now, but it's how do you get access to that data for other use cases. So if it's been stored at object storage or as file storage, how do we start to move it along the pipeline to the organized phase and then into the machine learning phase? Quite often these will be different systems. You'll need to do additional copies, and you end up with multiple copies of the data. You end up with a slow data pipeline, because you're again doing copies of these data points all the time before you can actually get to an organize, and then further copies before you can actually go on to analyze. So it's really about thinking through the complexity of storage along these processes, different storage types, different storage mediums, and media, and then also the additional copies that you may well have to do. So if I start to introduce really the key way that we address this with IBM Storage is to think about storage with a unified approach. And unifying data is not a new concept. There are it's something that we've been doing for a long time, being able to offer unified storage platforms. But when you're talking about the potential scale and size that you could have if AI becomes the leading kind of projects, the leading solutions to finding new ways to better the business, you can think about how quickly AI projects can scale. And that's where often many solutions come unstuck. So we have, number one, a software-defined approach. So that means that you can deploy this unified storage approach no matter where the solution lies. So whether it's out at the edge, whether it's sensor data and that kind of thing, we can stand up and build software-defined based solutions without the need for complex engineered platforms. They can be very easy to stand up, even on cloud resources, but then still ultimately creating this single namespace and this single data lake, effectively. That then applies further down the pipeline as well, with continued use of the same software, possibly now with engineered systems to bring additional performance so that you can do the analyze and machine learning phases with the right level of performance. But all in all, you've just had one single copy of the data that's in a single global namespace. And we also bring in, so on top of the two key software-defined platforms of Spectrum Scale and Cloud Object Storage, as we've lost the slides, we have this additional software layer of Spectrum Discover. Now, I'll keep going. Hopefully, Neil will be able to recover the slides. But we have the software defined storage layers, as I say, of Spectrum Scale and Cloud Object Storage. So those both can be used in isolation. They can be used in a combination so that you can have file and object storage, and they can both absolutely work towards giving you that single global namespace and that single source of the truth. On top of those platforms, we run Spectrum Discover. And Spectrum Discover is really about the cleansing of data, the classifying of data, and the organization of data. So with Spectrum Discover, we have the ability to look at system metadata. We have the ability to scan and work out what data is placed, where it's placed in terms of whether it's on a software-defined layer. And we have, thanks, Neil. and we have the ability to scan system metadata as well as then add custom metadata. So what we're seeing here, is the ingest phase is very much built out of the two key software-defined storage platforms that I mentioned, Spectrum Scale and Cloud Object Storage. In the organized phase, Spectrum Discover really plays a significant role. So think about video streams, think about file streams, sensor data, that kind of thing. You have the ability to read system metadata through Discover, and as I mentioned, that is just a case of where it's written, who wrote it, where did it come from, how long has it been stored for, when was it last written to, when was it last touched, that kind of thing. The platform allows you to go onto custom metadata tagging, and this becomes extremely powerful because you can go through many iterations of adding additional metadata. So think about the whole data pipeline here. You can start to set your own custom tags, so that when you want to run an AI project on a certain set of data, let's think maybe seismic data, you want to take seabed maps on a certain date, you want to know what kind of weather was there, you might have tagged the data already with the kind of weather information that was there, but you have the ability to effectively key in a Google type search across the data set and say, right, this is what I want to run. And Spectrum Discover will help pull all of that data from Scale and Cloud Object Storage automatically, so it gets it ready for the next phase, the analyze phase. But also, when you look at the inference, when you've actually run and got some results, you can put that additional custom metadata tagging onto that additional data as it comes out the other end. So all the time, you can keep refining and tagging and classifying the data throughout the whole process. So it can really help with this whole initial organized phase where we've seen data scientists spend as much as 80% of their time just organizing data in the first place. And you certainly can gain value by having a search-like function across all of the data that's stored in the organization. But when you start to think about the custom metadata tagging on top of that, it becomes increasingly more powerful. Moving on to the analyze phases, you start to have the ability to run fast, high-performance storage at this phase. And again, we can keep the same storage technology of Spectrum Scale. We can bring an engineered system called the Elastic Storage Server, or ESS, and that is tuned and built to run at high performance. You can always build your own because it's software-defined storage, but the ESS is IBM's custom engineered technology to run under that global namespace with extreme levels of performance suitable for machine learning and deep learning and training of the models. And again, the whole process, then you really need to start thinking carefully about what you do with the data, and the depth and scalability of ESS, Spectrum Scale, of cloud object storage, and then potentially bringing in even further software-defined technology such as Spectrum Archive. We can really look at the most advanced set of active archive technology that is in the industry, and we have this ability to run at different combinations for suitable use cases. So software-defined technology plays an extremely critical part in creating environments suitable for AI and certainly suitable for a data pipeline. And hopefully you sort of get the picture there that this is a consolidated view, a data lake that has a single global namespace, and therefore you have a single source of the truth, and you have this advanced Discover technology on top to help you find and catalog and tag data as the solution starts to evolve. So all of this can start at small small terabyte level solutions, and this is how I've been engaged with clients so far. Excuse me. We started with as little as 10 terabytes of Spectrum Scale to get a project going, but the real advantage is that we started with a small amount of storage. We know that when that solution proves itself, it's going to grow phenomenally, and Spectrum Scale has the unique ability to really scale on demand and to an infinite amount. There's no theoretical limit of how far you can take a Spectrum Scale single global namespace. So Neil, I think I've lost control just in terms of clicking. So if you're either happy to click or give back control, I'll keep going with, I'll give you a prompt to click if we need to. Okay, so the way that we work with our clients is, I've mentioned briefly earlier that we have reference architectures, and these can be built on converged platforms out of software-defined storage. But the key thing is that we have reference architectures to help put all of this together. From a storage point of view, it's heavily based on those technologies I've just talked about, and those technologies bring simplified usability to your storage and to your data. I'd encourage you to have a look at the many videos or ask us for demonstrations of this technology, and you can see Spectrum Discover in action, you can see Spectrum Scale, and you can see a lot more around the capabilities that are there. But it's really about starting small, starting with reference architectures, starting with a tried and tested solution, and one that scales extremely well. And that's really where we've had the most significant success, is demonstrating how just how much more we can scale. And in fact, now if you click to the next slide, please, you'll see we've been recognized in the industry and as to how we are differentiated from our competitors by the fact that the Spectrum storage for AI solutions have this scalability that is very difficult for any other vendor to come close to. Spectrum Scale has been developed over 2 decades now. In fact, it was built for media management, and it's been developed as a file sharing, media transfer, file-based platform initially, and it's become such a critical part of our software-defined storage product set because of its capability in both performance and scalability. So it really gives you a platform that you know is proven and tried and tested for growth. So as the AI project suddenly kicks the business into a new era, and data growth becomes something that you have to contend with to continue to drive that pace. It's a platform that you have the confidence in. It's not going to be a platform that suddenly spits out another silo and then another silo, because the scalability just can't cope. On to the next slide, please. Spend a little time on here. It's just a slide that I've included that gives you a little bit more around some of the reference architecture technology that may have been talked about on previous calls. So power technology, as well as IBM storage and computing platforms. We've got these reference architectures. We've got power technology, which is differentiated. We have the ability to partner with other platforms as well, and we've done the reference architectures on things like DGX. But then Spectrum storage is what really sets the solutions apart from a data and data management point of view. There's a couple of reference points there in terms of comments around how the platforms are significantly advanced in terms of their ability to cope with scale and speed. And as I say, certainly be happy for you guys to request of CSI more information, more demonstrations, and that kind of thing. It's all something that we can do in partnership with CSI. On to the next slide. Just a couple more points in terms of the proof points, and I think I'll go straight to the top of really sort of demonstrating and proving the technology, and that is with a couple of projects or a couple of HPC environments that we've designed and built, and Summit and Sierra are the top two most powerful supercomputers now in the world, and they're purpose built by IBM with a combination of our technology. And if you click to the next slide, please, Neil, you'll see some of the stats around what we've managed to do in terms of performance with these solutions. They are being put to incredible use cases right now, and there's a lot more that you can read about, perhaps in your own time if you're interested. But really, when you look at the capability and the performance that we're driving through these platforms, this is all built on a Spectrum storage data lake, so out of Spectrum scale, to be able to provide 400 petabytes of storage and data information to these supercomputers at these kind of levels of performance, 2.5 terabytes per second for single streams. It's incredible performance, and it's all built from technology that's available at the 1 terabyte starting point. Very low cost, very simplified, can really help you just put in a unstructured file storage environment for your AI project at very low cost in comparison to obviously the infrastructure that you might be looking at for the compute platform. But you've got the confidence that you can take it to a point where you don't have to think about copying out the data and moving between silos in the future. So I think on the final slide, for me, I just want a quick summary, and that is that we know that AI is being really proven. It's something that is here right now. Many customers are looking at how to deploy, but then many customers are being rapidly put off by the complexity and not knowing where to start. So again, think about reference architectures, the ability that IBM has to really give you a blueprint to follow. But really my message was about making sure that the foundation is there from a data point of view. If you have that foundation for storage and data from day one, it can be extremely low cost and simple to put in place, but it will stand up and be worth so much more as that solution starts to build and grow. And you have that confidence, hopefully you can see from the kind of proof points that we've got. And then you can think further, longer term, about lower cost storage environments coming in, such as cloud object storage for geo-dispersal across data centers as that lake continues to grow. And you can think about Spectrum Discover being a key component of helping you to classify and tag and keep control of the data and simplify the whole experience as it continues to grow. So with that, I would like to thank you for listening to a brief view of storage for AI. I'd welcome any questions if we have them right now, and I'd certainly welcome any further time with us in combination with CSI. I think those offers of workshops are incredibly powerful. Really start to think about how to set about planning, to talk it through, and we'd be happy to bring the storage skills to talk about those platforms and just find those starting points and talk about that sort of future ahead and just how far it might scale. So please do take up the offer of the workshops and getting back in touch with CSI and hopefully in partnership we'll talk to you soon. But with that, I'll hand back to yourself, Neil.
Thank you, Matt. That was great. Apologies for the loss of transmission halfway through. I'm not sure what happened with that. If there are any questions, we're happy to take them now. None at the moment. Okay, that's fine. You know where to get a hold of us if anything strikes you after the webinar. All that remains is for me to remind you of the next in the series. We're going to be talking about artificial intelligence and threat protection. We're going to have Paul Risk from Ignition Technologies with us, talking about how to use AI to become more efficient in protecting your organization's data and ultimately the organization's reputation. So with that, I'd just like to thank you for tuning into the CSI webinar. I wish you a pleasant day and a great rest of the week. Thank you.